This is probability note 7, probability distributions. Today we're going to create a probability distribution and graph it on a histogram, and we'll also calculate the expected value or mean of a probability distribution. We're going to look at a situation right here where we're going to consider a family with 3 children, let B equal boy, G equal girl, and we're supposed to list all the outcomes in the sample space. You may recall we did something like this earlier in this unit where we designed a tree diagram. I'm going to let this first branch, or the first set of branches here, represent the first child. The second set of branches represents the second child. And the third set of branches represents the third child. You can see we have 8 ends of branches here, so there are 8 total outcomes. You may recall with the sample space, I like to use the set brackets and write out all the possibilities. So this is our sample space containing 8 elements. Now here we said x is going to equal the number of girls in the family, and in the table below write down the probability that the family has x equals 0, 1, 2, or 3 girls based on how often these values occurred in the sample space we listed. Our sample space consists of 8 items, so we know the probabilities are all going to be out of 8. And maybe these are reducible, maybe they aren't, but we'll at least start with a denominator of 8 for each of these entries. The probability of getting 0 girls means we have 3 boys, and this happens right here with BBB. That's a 1 out of 8 chance. To get 1 girl, that could happen with BBG, BGB, or GBB. So 2 boys, 1 girl, that happens 1, 2, 3 times out of 8. 2 girls means we need to have 2 G's in our outcomes here. So we've got BGG, GBG, and GGB. That happens 3 times out of 8. And 3 girls is GGG. This happens 1 out of our 8 possible ways. This chart we finished off with is called a probability distribution. It lists each possible value for x and each value's corresponding probability. 2 things you should notice about the values in a probability distribution. 1, each probability is a value between 0 and 1. The smallest number you can have in this list is 0. The largest number you can have is 1. So no negative numbers, nothing above 1. Secondly, the sum of the probabilities equals 1. If you were to add these 4 probabilities together, 1/8 plus 3/8 plus 3/8 plus 1/8, you get 8 over 8. That's equal to 1, and that should always be the case when you add these probabilities together. Now down below we're asked to make a histogram and a scatter plot of this probability distribution. We're going to start with the histogram first. This is a graph that resembles a bar graph, but we do have scales on both axes. Along the vertical axis, we're going to write our probabilities. I'm going to label this P of x, and our probabilities range from 1/8 to 3/8. So each tick mark is going to represent an eighth. So this will be 1/8, 2/8, or 1/4, 3/8, and that's actually as high as we need to go. For our histogram, we do scales along the horizontal axis. These numbers are going up by 1. So if you want to, you can actually label the kind of interval values 0, 1, 2, and 3. We have our tick marks here for 1/8, 2/8, and 3/8, and what I'm going to do is on this 1/8 tick mark, we're going to have our bar at 0 go up to there. At our 2/8 or 1/4 tick marks, we're going to have our 1 value go up to there. And it's going to have the same height here for our 2 value. And then for 3, it was back at 1/8 again, so we do our bar graph like this. If you're asked to make a scatter plot of this distribution, basically we're going to use the same values along our horizontal and vertical axes. So horizontally, this time I'm actually going to put values on the tick marks themselves. So we're going to go 0 along the vertical axis, 1, 2, and 3. And we have our tick marks again representing 1/8, 2/8, and 3/8 along the vertical axis. To do a scatter plot, we're graphing individual points. This is like an x coordinate and a y coordinate underneath it. So we're going to graph 0, 1/8, 1, 2/8, or 1, 3/8, excuse me, 2, 3/8, and 3, 1/8. This would be a scatter plot of this distribution. The last thing we're going to look at is what's called the expected value or mean of a probability distribution. And in this case, we have this formula, which looks very difficult, but it's actually pretty easy to work with. For a family of 3 children, the mean number of girls or expected number of girls equals, well, we're going to use this formula here. And what this formula says is the expected value is equal to the Greek letter mu, which starts with the same letter as the word mean. So this is a mean, and for a mean we take a summation from I equals 1 to n of x sub I times p of x sub I. In other words, if you replace the i's with 1's, what we're going to do is we're going to take x sub 1 times p of x sub 1. And then we're going to go up to 2, 3, all the way up to 4, because in our table we have 4 different x values. Now, what's a little goofy in this problem is that our x values go from 0 to 3, but there are 4 of them altogether. Now, what we're going to do is once we fill out this formula here, what we're going to do is we're going to do some substitution. And what I'm going to substitute is basically the first, second, third, and fourth x values, which are the numbers 0, 1, 2, and 3. If you refer to our table, these are the 4 different x values in our table. And then we're going to write down the 4 corresponding probabilities: 1/8, 3/8, 3/8, and 1/8 again. We substitute these numbers in here. The numbers are going to be multiplied by the probabilities, and then these values are added together. You can type this in your calculator directly as you see it right here. You don't have to add any parentheses. You can just type in 0 times 1/8 plus 1 times 3/8 plus 2 times 3/8 plus 3 times 1/8. When you actually crunch this all out, you get 1.5, which should make sense because in a family of 3 children, the average number of girls should be half, 1.5.